Hello and welcome to this video where we're going through the GCSE Maths exam paper from AQA. This is June 2018, paper 3, and this is a calculator paper. There are some questions in here which are slightly different to the Maths Watch versions. Where those take place, you'll see the Maths Watch information in red. The same skills and processes are used for both. Let's begin. Question 1. Circle the value of the digit 7 in 9.17. This is the place value question. So the 9 is what we would call a units value. We would have a decimal point. Now the first decimal place is known as tenths, which would be a fraction of 1 over 10. The second decimal place is hundredths, which would be 1 over 100. Since that 7 is in the hundredths column, that means it is worth 7 hundredths, so that is the correct answer. Just to show you the difference between the exam paper version and the Maths Watch version, in the Maths Watch question they use the number 9.13 and they ask you to write that as a fraction. They give you the number 3 as the top number and they have a line, and your task is to fill in the bottom number, which in this case would be 100. Question 2. Solve 3x equals 2. 3x equals 2 means 3 multiplied by some number gives us an answer of 2. We can do a reverse calculation in order to work out the value of x. So the opposite of something being multiplied by 3 is dividing by 3. So we can divide both sides by 3. So if we start with 3x equals 2, we can divide both sides by 3, and that will undo the multiplied by 3 on the left, which will leave us with just x, and on the right we can write that as a fraction of 2 over 3, because that means 2 divided by 3. So there's our correct answer. Question 3. Which of these shapes has no lines of symmetry? Circle the correct letter. Well, some of these do have lines of symmetry. So shape B has a line of symmetry that is going diagonally. Shape C has a line of symmetry that's going vertically. And shape D has a line of symmetry going horizontally. Therefore, the answer is shape A, that has no lines of symmetry. Question 4. Circle the shortest length. So we've got 4 lengths. We've got 1,200 centimetres, 0.13 kilometres, 110 metres, or 140,000 millimetres. In order to find which of these is the shortest, we need to convert them all into the same units. So there's a couple of facts that we're going to need to be able to use. The first is that 1 centimetre is the same as 10 millimetres. The second is that 1 metre is equal to 100 centimetres. And the third one is that 1 kilometre is equal to 1,000 metres. So we're going to change each of these into the same unit. You can choose which one you want to use. I'm going to choose metres. So for the first one, changing 1,200 centimetres into metres means that we're using the conversion that 1 metre is equal to 100 centimetres. So if we're going from the unit of centimetres to the unit of metres, we're going from the number 100 down to the number 1, which means we are dividing by 100. 1,200 divided by 100 is 12. So 1,200 centimetres is equal to 12 metres. The second one, we've got 0.13 kilometres, and we're going to change that to metres as well. So this time we're using the conversion that 1 kilometre is equal to 1,000 metres. So if we're going from the unit of kilometres to the unit of metres, we're going from the number 1 to the number 1,000, which means we are multiplying by 1000. 0.13 multiplied by 1000 is 130. So 0.13 kilometres is the same as 130 metres. We don't need to do anything to the third number because that's already in metres, that's 110 metres. And finally we need to convert 140,000 millimetres, and we're going to change that into metres as well. Now you can understand that the word milli means that there's going to be 1000 millimetres in a metre, but I'm going to stick to using these conversions here, which means we're going to have to do two separate conversions to get millimetres first of all into centimetres. So from millimetres into centimetres, we're using the fact that 1 centimetre is equal to 10 millimetres. So if we're going from the unit of millimetres to the unit of centimetres, we're going from the number 10 down to the number 1, which means we are dividing by 10. 140,000 divided by 10 is 14,000. So 140,000 millimetres is the same as 14,000 centimetres. We're then going to do the same as we did on the first question by changing centimetres into metres by dividing by 100. So 14,000 divided by 100 is 140. Now that we have all of our units in the same format, so where they are all metres, we can choose which one is the shortest, and that's going to be 12 metres, which means that 1,200 centimetres is our correct answer. Question 5. Shade 2/5 of this grid. Now if we count the number of squares in this grid, there are 20 of them, which means we need to find out what is 2/5 of 20 and then shade that many squares. In order to find a fraction of an amount, we need to split that 20 equally into 5 sections. So we're dividing 20 by 5 to begin with. So 20 divided by 5 is 4. So that's 1/5 of 20. We are going to be taking 2 of those 4s. So we want 2/5, so 2 4s is 8, which means that 2/5 of 20 is 8, which means that we need to shade a total of 8 squares. Part B. Shade 10% of this grid. Now, even though the grid is a different shape, there are still 20 squares within that grid, which means that we are finding 10% of 20. To find 10% of a number, you are dividing it by 10. So 20 divided by 10 is 2. So 10% of 20 is 2 squares. So we'll just shade 2. Question 6. Sarge wants to go to all 19 home games at a football club. For each game, a ticket costs £28. A season ticket costs £379 and gives entry to all 19 home games. In total, how much does Sarge save by buying a season ticket? So we need to work out how much it's going to cost him to buy individual tickets. So this calculation is we are doing 19 tickets, because that's 19 home games. Each of those tickets is going to cost £28. So we're doing 19 multiplied by 28, which means he would have to spend £532 if he bought them all individually. The season ticket only costs £379, and we want to know how much he saves by buying a season ticket. So we need to work out the difference between 532 and 379, which means since we're finding the difference, that is a subtraction. 532 minus 379 means he's going to be saving a total of £153. Question 7. Link the algebra to the correct description. One has been done for you. Right, so each of these is something slightly different in algebra. The first and easiest one to spot is an expression. An expression is a piece of algebra that has no equal signs, no inequality symbols. It's just numbers and letters and nothing else. So the expression is going to match to this one over here, the 3x plus 2, because that's just numbers and letters with no other symbols. Next, if we have got an equals sign inside our algebra, that's called an equation. If we have got a symbol like this, that means less than. That means it's not equal to, it means that the value of 3x plus 2 is less than 14. We don't know what that is, but we know that it's got to be below 14, so it's not equal to. That means it's an inequality. Finally, we have an identity. Now, an identity is represented by an equal sign that actually has 3 lines instead of just 2. And that is reserved for when we have 2 sides of the algebra, 2 sides of this, that are always equal to each other no matter what the value of x. 3x plus 6 is always equal to 3 multiplied by x plus 2. If we expanded that bracket, 3 lots of x plus 2 is 3x plus 6. That is called an identity. Question 8. Jim has 6 banknotes. The value of each note is £5, £10 or £20. He can make £20 with 3 notes. He can make £55 with 4 notes. He cannot make £25 with 3 notes. He cannot make £25 with 4 notes. List the 6 notes. So to begin this, let's figure out what he can do. He can make £20 with 3 notes. Now, if we've only got these 3 numbers, there is only one way that we can pick 3 of them to give us a total of £20. That would be 2 £5 to make £10, and then a £10 note to make it up to 20. And since he can make that, that means we must have 2 £5 and a £10 to begin with. He can make £55 with 4 notes. Only way to do that is to have £5 to make it up to 5, a £10 note to make it up to 15, a £20 note to make it up to 35, and another £20 note to make it up to 55. Now, since we already have a 5 and a 10 within our answer, we only have space for these remaining 2 £20 in these spaces here, which means we've got one more note to fill, and we're going to use the remaining 2 pieces of information to decide which that is. So we're going to eliminate either the 5, the 10 or the £20 2 times to leave us with just one remaining note, which will be our final answer. Right, he cannot make £25 with 3 notes. Now, the only way to make £25 with 3 notes is to use a £5 note and 2 £10 notes. And we're told he can't do that. He's already got a 5 and a 10 within the answer, which means we are not allowed to add another £10, otherwise that would be possible. So we can't add another £10, so I'm going to remove that option. For the last part, he cannot make £25 with 4 notes. The only way to make £25 with 4 notes is to have 3 £5 notes to make 15, and then a £10 note. Now, in our answer, we've already used 2 £5 and a £10, which means we are not allowed to add another £5 in. Otherwise, that option would be possible, so it can't be a £5, which means the only note that is left that can go in this last space is another £20. Question 9. A music app has a shuffle play function. This means that songs are played in a random order without repeat. Part A. Ruth puts 10 songs on shuffle play. One of them is her favourite song. Write down the probability that her favourite song plays first. Well, out of those 10 songs, only one of them is her favourite, so the probability that her favourite song plays first is that one song out of a total of 10 possible songs. That answer will be accepted as 1 over 10. It will also be accepted as 0.1. It will also be accepted as 10%. Those are all equivalent to each other. 9b. Ted puts songs A, B and C on shuffle play. List all the possible orders of songs A, B and C. One has been done for you. So I'm going to start with this option. So this means that A is being played first, followed by B, then C. Now if we continue to say that A is played first, the next order could be that B and C are switched round. So A first, then C, then B, and that's all the possible ways that you can have these songs playing if A plays first. We've also got the options then to write down when B plays first and when C plays first. So if B played first, it could be followed by A and then C, or it could be followed by C and then A. If C played first, it could be followed by A and then B, or it could be followed by B and then A. So there are 6 possible orders of songs A, B and C being played on shuffle. Question 10. Here is a scale drawing. The Ferris wheel has a height of 130 metres. Work out the height of the building. Now, since this is a scale drawing, that means that these two are in some sort of proportion that we need to figure out. That means we need to measure them to find out how tall they are, so we can find out how much they are scaled up. So, if we measure the Ferris wheel is 2 centimetres tall. The building, on the other hand, if we measure that, is 10 centimetres tall. So we've got 2 measurements and we need to figure out how much taller the building is than the Ferris wheel by saying what do we do to the number 2 to turn it into the number 10. 10 is 2 multiplied by 5. 2 times 5 is 10, which means the building is 5 times bigger than the Ferris wheel. In reality, the Ferris wheel is 130 metres tall, which means the building is 5 times bigger than that. And 130 multiplied by 5 is 650 metres tall. So that's the height of the building. And question 11. This is going to be the last question of this part of the video. Joe has a full cup of coffee. This cup is 10 centimetres tall. She drinks some of it. So once it's been drank, it is now only a depth of 5 centimetres in the cup. She says half the coffee is still in the cup because 5 centimetres is half of 10 centimetres. Is she correct? Tick a box, yes or no, and give a reason for your answer. So just if we were looking at just the numbers 5 and 10, you would think that 5 is half of 10, so that's half the amount of coffee. However, if you look at the shape of the glass, the cup, it is wider at the top than it is at the bottom, which means the top half of the cup would actually contain more coffee than the bottom half. Therefore, she will have drank more than half by just drinking that top from 10 centimetres down to 5. So no, she is not correct. And an answer that is acceptable is that it is wider at the top than it is at the bottom. Just writing it is wider at the top was enough for that mark. That is the end of this first part of the video. Join me for the subsequent parts for question 12 onwards.